Hello. Today we're going to talk about acids and bases, because acids and bases usually, although not always, exist in aqueous solutions. So we're going to talk about them and how they react together. So we learned last year that an acid was a substance that in solution would donate a hydrogen proton, a hydrogen ion. An example that we gave last year for acids was hydrochloric acid, HCl. When you put HCl in water, it breaks up completely into H plus and chloride ions. And so because you have this H plus there, that it donates this as an acid. Now, today we're going to broaden this definition to say that an acid is anything that donates a proton. This H plus is a proton. Here, the HCl is donating a proton to the water or to anybody who wants to take it. So we're going to broaden this definition to say that an acid is anything that donates a proton. Last year, we said that a base is something that in water creates a hydroxide ion. This is the Arrhenius definition of a base. And we use the example of sodium hydroxide. You put that in water, and it breaks up into sodium ions and hydroxide ions. Now, today we're going to broaden this definition a bit. Oopsies. And we're going to say that a base is anything that accepts a proton. Because, as you can see, hopefully, if this hydroxide ion is floating around in water and it meets up with a proton, hello proton, it's going to accept this proton. They're going to join forces, and it will become H2O, or you could write it as HOH. So this hydroxide, because it has a negative charge, is ready and willing to accept a proton, and that's why we're going to call it a base. We're making definitions right now. So in chemistry, we need to define the word strong. And we're going to define the word strong as anything that breaks up or dissociates completely. Anything that breaks up in solution, or the word for that is dissociates. And the key here is completely in solution, in aqueous solution. Let's give an example. Hydrochloric acid is a strong acid because when you put it in water, it completely breaks up into hydrogen, protons, and chloride ions. I'm going to write the aqueous here. What that means, so here we have a picture, it completely broke up. What that means is in water, if we were to put some hydrochloric acid in here, I'll draw it in red, it would exist, it would completely break up into hydrogen and chloride. They would be floating around separately, no longer together. There would be no hydrogen chloride bonded together. You would not draw it as two circles linked together if you were going to show it, because they're not going to be together. They've divorced. They've become separate in water. They break up completely. That is the definition here of strong. I'm circling it. You are going to have to memorize the strong acids and strong bases. There are only 7 strong acids: hydrochloric acid, hydrobromic acid, hydroiodic acid, I don't know how to pronounce that, chloric acid, perchloric acid, nitric acid, and sulfuric acid, only for the first proton. We'll talk about multiprotic acids later. You can guess or infer that since there are only 7 strong acids, most acids are weak. And we're going to talk about what weak means in a second. The strong bases, these are the strong bases. Anything, well, the group 1 metal hydroxides. So group 1, the alkali metals, when they combine with a hydroxide, those are all strong bases. Lithium hydroxide, sodium hydroxide, anything group 1 metal and hydroxide is a strong base. And the heavier group 2 metal hydroxides, calcium hydroxide, strontium hydroxide, and barium hydroxide. So you have to memorize these. Go to it. Now, we're going to talk about what the difference is. I'm going to smush this. Move. Why did these things get this happen? We're going to talk about the difference between strong versus concentrated. We already defined strong. It means it breaks up completely. Completely. Concentrated just means you have a lot of it. But you can have a lot of you can have a concentrated weak acid. You can have a concentrated solution of sugar. So that's different. It's different to be concentrated. Let's see, what is a weak acid? Acetic acid is CH3COOH. That is a weak acid, but we can have concentrated acetic acid. That means we just put a lot of acetic acid, which is vinegar, or which makes vinegar, into water. You cannot have strong acetic acid, though. That does not work. Now let's compare the word strong versus weak with respect to acids and bases. If you're weak, that means you do not break up completely. An example of a weak acid, as I mentioned before, is acetic acid, CH3COOH. When we put this in water, it does not dissociate completely into acetate ions and hydrogen protons. It only breaks up a little bit, so most of it will still exist as CH3COOH. And only a little of it will exist as a proton and the acetate ion, which we write like that. So the way to show when you're writing symbols that something is weak is you use two arrows. And this is not going to let me erase this. You would have you would have the acid over here, arrows going both ways, and then the proton and the ion. And what that tells you is that most of it exists in this form, and very little of it exists dissociated into the proton and the ion. That's what weak means. It does not break up completely. We're going to talk more about acids in chapter 6 in the spring, but we need to start learning about them now. So let's practice. We're going to compare acid strengths of these three acids. We have HX, the H signifying that it's an acid because when they write the H in front, you're showing that that proton could be donated. HY and HZ. So usually whenever there's an H in front, that's an acid. We're going to rank them in order of strength. The water molecules are not in the picture so that we can just focus on the acid, the protons, and the anions. So let's look. Which one is the strongest? Pause it and you think about it. Then unpause. HY is the strongest acid. So I'm going to write that here. And the reason HY is the strongest is because if it started out as a negative ion paired with a proton, this has completely broken up into anions and hydrogen protons, the white things that have the positive charge. It has completely dissociated. Now let's find the weakest. In each case, we started with 8 molecules of the acid. I know that because I counted the anions. Well, actually, I counted the whole thing. So HZ has dissociated into 3 protons and 3 anions, and the remaining 5, so we have 3 H pluses and we have 3 Z minuses, and then we have 5 HZs. On this side, the HXs have dissociated into 2 H pluses, 2 protons, one's over here and one's over here, and 2 X minuses, and the rest of what's in the water is HX. HX has not. These that I'm circling have not broken up. So there are 6 HXs that did not break up in this picture. So this one, HX, is the weakest because it only had 2 of them dissociate. It is the weakest. And the one in the middle is the one that had 3 of them break up. The H, that was HZ, right? So strongest to weakest. I'm going to end this video here and start with the next slide on the, so these videos are not too long.